Welcome to the Lessons Learned video of the Aspire project. In this video I will not discuss all results and new scientific knowledge that we developed. Those great outcomes of our project are the subject of another video. Instead, in this one I will briefly iterate over some of the other lessons we learned while implementing the project and developing our solutions. First of all, the academics learned a lot from cooperating with companies. Companies schedule their resources much more strictly, and academics had to learn to live with that when close collaboration was needed. Actually, for some partners, simply learning to work with so many different partners was a learning experience by itself. Academics also learned a lot about software development and security from the companies. They learned about real-world software development lifecycle requirements and about how companies think about security requirements and attack models. All partners learned to collaborate better during the development of the common toolchain. This toolchain has lots of dependencies between the components, but we still were able to keep a strong separation of concerns. The end result is the plug-in design and implementation of the Aspire compiler toolchain. While developing this toolchain and reasoning about ways to evaluate software protection, it also became clear that researchers working mainly with source code on the one hand, and researchers used to work with binary code on the other hand, look at the issues at hand from a rather different perspective. And this gap had to be bridged during the project. Now, the collaboration was successful, even though the bar was set quite high. At the start of the project, we had to choose the use cases we were going to implement and then protect with the developed technology. We had to decide on several aspects that were going to make our lives more easy or more difficult. Of course, more difficult means more realistic and hence more valuable if successful. On each aspect, we chose the more complex option. We did not focus on Linux, but on Android. We did not choose to work with command line applications, but with applications with graphical user interfaces. And we did not choose to protect standalone binaries, but we decided to protect dynamically linked libraries instead that get loaded into the GUI apps and into complex multi-threaded Android server processes that we do not control. All of these choices made the deployment, integration, testing, validation and demonstration of the developed protections much harder. Some protections that seemed promising at first also proved to be completely unworkable on these real-life use cases. But the end result is of course that our technology is now really proven and much more ready for exploitation. Through penetration tests of various sizes and with various types of pen testers, we tried to evaluate a lot of the developed technology. We used academic students as well as professional hackers, and we even involved the public in a public challenge. Besides some concrete insights we obtained regarding specific protections, for which I refer you to our long list of public reports, we learned a lot regarding the design and scope of penetration testing experiments. One of the lessons is that it is very difficult to simplify the objects of the experiments and to still get very useful results. When the binary under attack is too small, or when only a few protections have been deployed on it, attackers adapt their strategy. On overly simplified cases, the attack path of least resistance is not always representative for real-life use cases. We also observed that it is very difficult to combine multiple protections such that they really cover all possible attack entry points. In practice, only a number of entry points are closed and attackers easily find the remaining ones, even if it costs them a lot of extra effort. Of course, by forcing this extra effort on them, we still reached our goal. Finally, another lesson we learned is that there likely is a gap in granularity and complexity between automation tools and humans when they think about the best protections to apply. Our current understanding is that a decision support tool that has to select protections to apply can reason about attacks in a quite coarse-grained fashion. Human experts, on the other hand, want to be explained the decisions in terms of fine-grained, precise attack steps before they can start to trust that decision support tool. So here as well, there is a gap that we still need to bridge.